Today's lesson is on postulates and how they fit in with undefined terms and definitions is really the focus here for today. We do get some other properties as well that we're going to talk about. The 2-point postulate basically says this: through any 2 points, there exists exactly one line. This was one of Euclid's postulates or axioms. And it basically states the obvious. If you have 2 points, you can only draw one line through it. Now, the line point postulate is just the opposite. If you have a line, there are 2 points. There are at least 2 points, I should say. Okay, now the line intersection postulate is very simple. If you draw 2 lines and they intersect, they're going to intersect in 1 point. The 3-point postulate, and we've talked about this in class with the chair, remember, we always have 3 points that contact the plane, the floor, the ground. That means those points have to be non-collinear, and that determines a plane. So a plane has at least 3 non-collinear points. The plane line postulate states if you have 2 points that lie in a plane, then the line connecting them lies in the plane. And then the last postulate we're going to talk about today are if we intersect 2 planes, they intersect in a line. Just exactly what we talked about earlier this year when we went over points, lines, and planes. We interjected many of these concepts into our discussion. So, state the postulate illustrated by the diagram. Well, if 2 lines intersect right here, if 2 lines intersect, as you can see right there, then their intersection is a point. So that's the postulate. On B, if 2 planes intersect, then they intersect in a line, in 1 line. Okay, now it says use the diagram to write examples of the plane point postulate and the plane line postulate. Okay, well, do you see 3 non-collinear points? I do, B, A, and C. What plane do B, A, and C make? Plane P. So there's the plane, basically the plane point postulate. Now, notice I see 2 points, BA. If you draw a line through BA, they are also on plane P because BA is on plane P. B and A are on plane P. So that's kind of illustrates that point. Now, example 2 says use the diagram for which postulate allows you to say that the intersection of plane P and plane Q is a line. Well, it's the parallel, or it's the intersecting planes postulate, right? Right here, the plane intersection postulate, because 2 planes intersect in a line. Now, use the diagram in example 2 to write an example of the postulate. 2-point postulate. Okay. Through any 2 points, there's 1 line. Yep. AB, there's 1 line right there, N. Line point postulate. So through any, what was the line point postulate? If we go back here, a line contains at least 2 points. Well, here's a line. It contains at least 2 points, B and A. And then the line intersection postulate, this is line M, this is line N. They intersect in 1 point, A. So those postulates are all shown in that picture. Now it says sketch a diagram showing line TV intersecting segment PQ at point W so that TW is congruent to WV. Okay, so sketch a diagram. Here's TV, TV, intersecting segment Q at point W. So there's PQ intersecting at W, such that TW is congruent to WV. Well, there's a picture of it. There's what that would look like. Okay, which of the following statements cannot be assumed from the diagram? And this is where you have to be very, very careful. You can't assume too much. So which one of these things cannot be assumed from our picture? You have to be careful here. I'll let you think about it for a second. Can you assume that A, B, and F are collinear? I believe we can because there's a line through it and they're all on plane T. So this can be assumed. How about E, B, and D? Can we assume that these make a line? I agree. You cannot assume that. How about line AB is perpendicular to plane S? Line AB perpendicular to plane S. Yes, indeed, you're right. Because there is a right angle right there, so that can be assumed. How about line CD is perpendicular to plane T? Can you assume that this line is perpendicular to T? Well, if this line right here is perpendicular, then wouldn't this line also be perpendicular to plane T? That would also be a right angle, wouldn't it? I think it would be. We can assume that. And line AF and line BC intersect at point B. I think that's obvious. We can assume that. It's only one thing we cannot assume there. Now, if we refer back to example 3, if the given information states that PW and segment QW are congruent, how can you indicate that in the diagram? Okay, so PW and QW. How do you indicate that? Well, since I have tick marks here, I would have to put double tick marks there, and that would indicate that those are congruent. Okay, going back to that problem. Now, name a pair of supplementary angles in the diagram. Now, this goes back to our last lesson. Name a pair of supplementary angles. Well, that would be any two angles that add up to 180, right? So these two would be supplementary. So TWQ would be supplementary with QWV, as well as these two. So we could go around. There are 4 pairs that are supplementary. All right, so now we're going to go back to example 4. I got these out of order. Here's example 4 again. Can you assume that plane S intersects plane T at line BC? Can we assume that plane S and plane T intersect at line BC? I think we can. Yes, we can. How do we know that line AB is perpendicular to line BC? How do we know they're perpendicular? Because this plane and this line are perpendicular. I see that 90 degrees there. So therefore, those would have to be perpendicular. Okay. The assignment then is on page 463, and we're going to do numbers 3, 4, 13 through 20, 23, 29, 30, and 34. And those are just talking about postulates. And really, that postulates are